Hello everyone, welcome back to another video. I am Vaibhav and we are going to see our today's video topic is queues in Java. In our previous video, we are seeing a stack. So queue is the same type functional as a stack, but in queue there is a same as our stack. It is a similar data type of it is a collection of similar data type of object which is stored or which is collected in a one array or in a one manner, set in a manner. So we see this queue, but also we are seeing referencing the difference between stack and queues. So you will get easily understand the difference between also stack and queue, and what are the main aspects of queue, or what are the main disadvantages or advantages of queue. So let's start. So firstly, our queue are having two opening, but in our stack there is only one opening with which is having which performing insertion and deletion operation by the one opening end. But in our queue there is a two different openings are there. That means we are achieving insertion from one end and deletion from another end. So uh, in our queue there is a two ends are there. That is, one is our front and another is our rear. So before that going our queue, we are seeing a real life example for that queue, so we can easily understand how to what is our actually queue will be works. In our queue, there our queue is works on a principle of FIFO. That means first in, first out. The element which is first in that index, that will be out firstly. We can see with the help of example. All we know, there is a movie ticket counter. That time in the counter firstly is empty. When someone person is going for getting the ticket, firstly that person will get the ticket first. After that, second, third, fourth, fifth, all the queue will be created, but the which person will be comes firstly, that serve firstly. That means first come, first serve concept is there. Our queue will be also performing that like that. The first element which is come in our index, that will be removed firstly. In our previous video, we are seeing a stack. In that stack, there is a reverse concept. That means the last element comes in their index, it will be removed firstly. They are having a concept. They works on a LIFO. That means last in, first out. And our queue is works on concept FIFO. That means first in, first out. So basically, our FIFO are having different objects. We can see all these objects. Their objects are there are different objects like NQ, DQ, peak, is full and is empty, and searching methods. So we will be see briefly all these objects. So firstly, as we seen in our stack, there we are using a terms like insertion and deletion. But in our queue, we are using for insertion as NQ, and we are using a DQ. We are using a DQ as a deletion. In our stack, we are using a insertion for inserting the value, and deletion for removing the value. And in our queue we are using a EQ for inserting the value, and a DQ for removing the value. So in our queue, at there is a two openings are there at our front, at our front end. They performing a operation for a DQ, that is our having zero index, that is performing operation for DQ, and at our last index there is our rear. They are having queue are having front and rear, two openings are there, and our rear end will performing operation for the NQ. That means inserting the data from rear side and removing the data from front side. This is the basic logic for it. So we will see how they all functions are works. Firstly, the first object is NQ, that is insertion. That means inputting the some values, specific values or some specific element. So there is not a rule for inserting only values. There we are using different types of data like integer, string, float. All the types of data we will be inserting in our queue. But only one condition is that that data should be having a same data type same data type. That data will be set in a specific manner. We will set the data within a specific manner. So we seeing our first object, that is enqueue. With the help of enqueue, we performing the operation of insertion. At the time of we are using the enqueue, our element will be inserting in our queue. That is the basic know about insertion. After enqueue, after that next object is dequeue. Dequeue will be perform operation on our front side. That is our zero index. It perform operation from a zero index or our front. That means our dequeue means we are removing or getting a copy of that element from our front side. That is our dequeue. After that, next is a peak, or we can also call as a front. That means in our dequeue, that time if we are using a object of dequeue, that time we are removing that specific object from our zero index or from our first index. But when we are using a peak, that time we only read the copy of that first element which is stored at a front. That time we are not actually removing that element, we only read the copy of that first element or the element which is at the position of front. That is the difference between peak and dequeue. After that, our next point is full. We are using is full for checking a boolean type condition. That means if our cube is completely full, consider our cube having a size of 5, that time again we are calling the method for the enqueue, that enqueue for inserting the elements. That time it will be show as a comment, as a it goes for the comment of overflow. That means it should be out of bound of the size of our cube. It is out of size of our cube. That time our condition will be true. That means our object of is full. It should be performed as a true condition because our cube is a full. That means is at the end of is their size. And next object is that is empty. Is empty is performing a vice versa operation of is full. That means if there is a our cube does not consisting any element, that time again we are calling for the dequeue. That means for calling for object for the dequeue, that for the removing the element from that our cube, but there is not any element is present in queue. That time it show underflow condition. That means there is not any element presence in the queue. So that time it our object of our is empty will be true. That means the queue is completely empty. So we go towards the how actually flow will be performed in the queue. We can see directly with our example. Let's consider there is any queue which having a length of 5. That means it's having a capacity of 5. That means the index of that queue will be 0, 1, 2, 3, 4. The size of queue is 1, 2, 3, 4, 5, but it's indexing as 0, 1, 2, 3, 4, 5. So at initial level, our front and rear will be at the same position. That is in our first position. That time it algorithm like a front is equal to rear is equal to -1. That time our whole queue is empty. When we are using a command like enqueue, that time we are putting a element within that our queue. That time our front will be increased by plus and end will be also increased by plus. That time it moves toward a zero index. That means firstly it having a minus one condition. Our front and rear are having at a minus one position. When we are using a command for the MQ, that time it will be goes for first. It will be goes toward the zero index from minus one to zero index because of plus. That time it performing the operation. But when we are again giving the again using the NQ object, that means the inserting one more object, that is our object 2. For that time our only rear will be plus plus. That time our front will be fixed at the zero index. That means again after we are using a more operations for a NQ, that only increasing the index value of our rear by 1. That means as our if consider if we giving a 3 NQ condition for a 1 2 3, that time our end will be moves from a 0 to 1 2 3. That means it goes only it moves only rear indexes, but our front index remains at that position because we are performing different operation from our front indication, that is a deletion, or we are called as a DQ. So it goes up to the we are performing that object again and again. We are performing that object of our NQ again and again up to the length of our Q. We are using a first increasing condition up to the our Q. If we are increasing the if we are giving the condition out of, consider my length is length of my Q is 5, but I am giving elements, or I am giving a NQ for the six elements. That time it will be show out of bond, or it will be show overflow. So that time it does not use the inserting the element within that our Q. It shows the message for a overflow. Like as when we are using a DQ, that means that time we are removing the element from our first from our front, that is DQ. When we using a operation object of a DQ, that time element will be removed from front side and our indexing will be plus plus. Our indexing of front will be plus plus. That means it moves from a 0 index to 1 index. As we see, firstly our front index at our front is an 0 index. After we using a DQ, that time our index will be plus plus for the front, and it moves toward the first index from 0 to first. So that time the element which is stored at the first position or at a 0 index, that will be eliminated, but that value is existing at that index as a garbage. We will discuss what is garbage in our next video. Before that, we seeing this concept. After we are increasing, after we are using continuously that DQ, or we are removing continuously the value from our Q, that time it travels from the initial index to the last length index of our Q. Consider I have that we are having a Q of 5 size, and we are continuously eliminating the one by one element from our Q with the help of DQ. Consider size of 5, and we are decubing 6 elements. That time our index of DQ goes out of bond. That time there is a one more condition is that if our start is or our front is greater than end, that time also our Q will be shown as empty. Okay, so that is the one of the most drawback of our Q. That is, if we are traveling from if our front is traveling from 0 index to last index, that time it removing the element from that indexes, and index will be increased by 1 and that index goes toward the last point if there is a condition as like a start is equal to end. That means both our front and rear at the same position at end. That means our front is equal to end. That time it show as a mm, our whole array is as a full, but at the real time our queue is empty because we are removing all these elements, but the garbage of that all element is remains in that indexes. We can override that indexes, but after our last index we can use a if we are using a insertion for that case, it shows the message as a our queue will be full, our queue as a full. It shows that message because our indexing of our front is go at a last time. That because of that it shows the full. That is the major disadvantage of our queue. We can avoid that. We can resolve that disadvantage by using a circular queue index. So what is circular queue index? We will be seen in our next video. So that is the overall flow of our overall flow of our queue, how queue is actually performed. We see the some examples some real life example for on it. We know the printer, which is consider there is any printer in office, but that printer will be connected with the 4 to 5 PCs. When our first PC will be giving a print, that time the print will be that print command will be directly performed. But consider if at a time that first PC, third PC, second PC and fourth PC at a time they are commanding for the print, that time that overall data will be stored as in the form of queue. It will be performing their operation one by one as the sequence of their coming. That means as the sequence of their their order, the first command of printing will be executing firstly, after that second, after that third. Then like that it will be performing operation like a queue. And one more example, like in our call centers there is also using a queue function. If customer will be called that at the customer care, if their servant will be in a busy on another call, that time it putting on our hold with the help of queuing method. That means at the time customer servant will be free for the call, that the customer which is at hold firstly, that customer will be take the call for that customer servant. That is the overall concept of our queue. Thank you.